Hi, hello all. Before I start my presentation, let me introduce myself. I'm Dr. Dinesh Kala from Khalsa College. I'm heading the Department of Physics now. As most of you are aware, we have got a webinar on 30th August based on solar and solar solutions. Let me have an introductory talk what exactly we are going to plan on that particular day. And after having this topic done, I think you'll be able to get an idea what exactly we are planning for. What is our main concern is that I'll just go through a few sentences first and then we'll discuss in detail. We know most of the electrical and electronic experiment in physics lab runs on regulated DC power supply. All the physics students knows, those who have done their practicals in 11, 12, first year, second year, third year till MSc, that for example, I want to run a gate based IC. For example, a gate having NAND gate or a NOR gate or XOR gate and so on. It just works with 5 volt. And that 5 volt is coming from a supply which is called the DC regulator supply, which exactly gives me 5 volt. That means I am able to run some of the experiment in the lab just with 5 volt, some of them with 12 volt, some of them with 15 volt, and like op-amp circuits maybe with plus minus 15 or plus minus 12. The ultimate is we are running all those circuits with DC power supply. We hardly use any appliance or any device or any instrument in the lab which actually works on AC. But you all know when we are talking about the DC power supply, exactly when you start working with the power supply, you have to plug in into AC only, AC socket, where you are receiving 220 volts. So what is common is that we are getting 220 volts. But the important thing to remember and recollect is that everywhere we are having 220 volt AC, but when we need to work, we work exactly with DC in most of the cases. Similarly, if you are charging your mobile through solar energy, your consumption will be reduced drastically by 60%. I think all of you know there are two ways to charge your mobile. One way simple is put your adapter of your mobile in 220 volts. Finally, what comes out of it is hardly 5 or 6 volt DC and it is able to charge your mobile. Any best possible mobile does not require more than 5 to 6 volts, so more than sufficient. Other method is, assume you are working on a laptop and you just have a USB cord with you. There is a socket of USB in a laptop and you can connect your mobile for charging there also. Exactly what is happening? From the AC mains through the adapter of laptop, AC is converted to DC. The battery of the laptop getting charged, and through that battery exactly you are charging your mobile. In a complete sense, it's very clear that if I've got a DC source available to me, like your plug in your charger, mobile charger to a laptop, I can charge with a DC. Exactly, I don't require any AC source and an adapter, and then the adapter inside is quite a complicated circuit. The power supply inside has got a quite complicated circuit. Power supply inside quite complicated circuit, I mean there are many circuits required within a DC power supply which exactly converts your 220 volt AC to just 5 or 12 or 15 volt DC. That means there's a lot of loss in energy, exactly when you convert AC into DC. Let me discuss through circuits also. So if you are charging a mobile through DC source directly, your consumption is 60% less. No need of less efficient transformer. Even the circuitry inside the adapter is no more to reduce any energy because you don't need any adapter. You just need a USB cable. This I'm talking about how to charge a mobile through just a USB cord. Nowadays mobile is coming with the facility of adapter where you can connect the wire, where you can disconnect the USB wire. So you can connect it anywhere where there is a DC source available. The adapter simply convert AC into DC. That means I've got a battery. Now what exactly, how you charge a mobile through the that battery bank. Same way, battery bank is charged and then you are charging a mobile. So actually mobile can be charged through a DC source. We don't exactly need an AC source. Our intention, our struggle, our main point is if DC is available, why does it need to convert AC into DC and then working on DC? You'll come to know in detail what exactly I'm talking. Now, this is an interesting thing here. Not only about charging and all this mobile and all, even the power supply. When you talk about the DC fans, not normally, we have got AC fans at your house because they are working on AC. AC means alternating current. DC means direct current. But you'll surprise if you use a DC fan or DC bulbs compared to their counterpart which are AC bulb and AC fans, the consumption is 70% less. That means if I replace all my AC appliances by my DC appliances at home, whatever bill I'm getting today, for example, if I'm getting 3,000 rupees bill, it will go down to 70% less. So you can imagine how much amount you'll be saving without losing any comfortability. Similarly, a 25 watt DC driven fan is the same as 100 watt AC fan. See the difference? And fan wise, I don't know, you may have experience, but bulb wise you have experience. A 20 watt LED bulb, nowadays we are getting either from a good company or from an average company, gives much more intensity even compared to 60 watt or maybe sometimes 100 watt bulb. So wattage if reduced means energy consumed per unit second reduced. In total, the bill you have to pay get reduced. So question is, when DC sources are available, just by replacing DC loads, why not to convert or use DC sources rather than AC sources? I'll give a very typical example. I'll come to this diagram very soon, but before that, just see this diagram. This is a very interesting diagram. When we connect an adapter to a AC socket, what exactly happens in that adapter is either it is a mobile adapter or is a laptop adapter or any adapter which is made to give you DC out of AC. What exactly is there is, you have got a transformer. You can see one transformer here. You have got a rectifier. You have got a filter. You have got a regulator. And there got a load. This load I can call for the timing is my laptop, which I am charging. And this transformer exactly, the AC which is coming in your house, it converts high voltage AC 220 into lower voltage, maybe 22 volt, maybe 30 volts. See, there's a drastic change here itself. You are bound to convert 220 AC into 22 AC. That means it is AC only, but the voltage gets reduced because I don't require 220 anywhere. So I have to reduce it. Then if you see very carefully, it is given to rectified circuit which actually convert AC into DC. So output of this rectifier circuit is exactly like this, which is not proper DC. Proper DC is when you get a straight line like this, But with using a filter and a regulator, you can expect that if I am expecting 5 volt here, from my 220 volt AC, I'll get it. I'm getting it. I'm using it. We are working on it. We are relying on it. But remember, You are converting 220 into 5 volt. So you can imagine the loss of energy between these interfaces for no reason. No reason why I'm talking. If we switch over to DC source, assume a 5 volt DC source, then all this circuitry I'm out. And I can connect my, for example, this is my DC source directly to my load. And that's all the same purpose as this whole configuration does. Now let me tell you what exactly I'm talking about. If you see very carefully, now this is, we are compelled to use AC because generators and at nuclear plant and at the coal plant, wherever AC is being produced, the advantage is if the plant is too far from your house and society, you need to convert low voltage into high and high to low, because communicating DC is really difficult. I mean, transferring DC from one place to other place gives a lot of loss. That is the only negative point. But that can be eliminated. Nowadays what we are doing is, we have got this solar based system where there is a panel, and the sun when gives rays and falls on the panel, it converts directly sun energy into voltage. That's a beautiful part. That created a lot of change in the energy program once you got this panel system. But here what I want to emphasize is, this actually is connected to a charge controller. This panel is connected to charge controller. From charge controller it is going to a battery bank where the batteries are being charged. Remember, this is your solar, this is your charge controller, which takes care of this battery to charge. Take of battery charge is very important. Sometimes what happens, battery, there may be very nice sun intensity on a particular day, and it may be possible that there is a lot of energy being produced, so the battery may get overcharged. That has to be avoided, that has to be restricted, that spoils the life of the battery. So this charge controller has a very important role. And then to the battery we can connect to an inverter, and this inverter gives you exactly same 220 volt as coming in your house. And then if you connect to a house or your grid at house, you'll be working, you'll be able to get the energy and use the energy the same way as you're using electricity today. My concern here is, I'm having this solar panel which gives me DC. I'm using this charge controller and I'm charging the battery, and then I'm using an inverter, and then again I'm just supplying to my house. But the interesting part is, when it reaches to a house, and as a simple example of charging a laptop, again what do? You have to convert that 220 down to again 5 or 6 volts, and then you can charge your mobile. My question is it not possible that if this system is giving me a DC, then why can't get eliminated of all this configuration and connect to my house and can charge my mobile? But the question is, charging mobile, charging laptop, you can have, you have to make the change in the charging system. Then I can have a DC fans, DC based fan, DC based light. I have so many things in my house which I can change. I'll be out of all these circuitry, and I'll be able to use my solar panel energy directly. See, the energy from sun is already free. Solar panel makes a good conversion for that. My intention from so many years, my concern from so many years was, if most of the things works on DC, why to use this configuration when panel is already giving me DC? And then, for example, instead of house, I am working in a lab. Most of the power supplies are giving either 5 volt, 12 volt, or maybe plus minus 15, whatever it is. With a slight modification, the output voltage of this panel can be converted into the required voltages. Your whole lab can work on that particular DC. There's no need to use AC and then conversion and then. So in that case, in that case, what is the simple thing I am going to get is, in this configuration, all this circuitry will be replaced. I'll have simply panels. Let me represent these panels here, which is equivalent to a battery. Obviously, you require some modification that how you can get a stable DC from a panel. This required circuitry will be there, but it will be out of all this. And then your load can be my laptop, my mobile charger, anything working on DC. I can have a fan. You wouldn't believe a DC fan just works with 12 volt. 12 volt DC fan. Imagine 220 AC fan and a 12 volt DC fan. This discussion clearly tells that how much energy saving you are able to do. Now, question is, how can I talk this big? Let me tell you. We have set up a lab in our college, and everything I'm showing you now is working on DC. Not only DC, everything is working on 12 volt DC. It's very interesting. That means if wattage of a load is changing, voltage being same, it will work on different currents. For example, I've got a 40 watt fan and I've got a 20 watt fan. So how much current will be flowing through 40 watt will be 40 by 12. How much current will be flowing through 20 watt fan will be 20 by 12. Actually, every load is distinguished and differentiated by its current holding capacity or its wattage, what we call it as. In your house, everybody is working on 220. Where it differs? In the wattage. Your geyser will have a different wattage, your fridge will have a different wattage, your TV will have a different wattage, your mobile will have a different wattage. So wattage varies. Wattage varies means voltage remains same, current will be different, wattage is voltage into current, so wattage will be different. So for 40 watt bulb I'm talking and about 100 watt bulb I'm talking, both works with 220. 100 watt will withdraw more current, so more intensity. 40 watt will withdraw less current, so less intensity. Now see, what exactly I'm talking about is, here you can see we have got just 9 watt DC LED lamp. You can guess how much intense it is. Just 9 watt DC LED lamp. It is working on a battery, and that battery is charged through solar. So to get a stable output, we require a battery in between. But with a slight modification, the solar output also we can get it without the battery. But it's better to save the instruments and the components, the devices, if you are working through a stable output that is giving from a DC. Now, if you see this, you have got a watt meter, the very interesting device. It's a microcontroller based. It not only tells you how much energy is coming to your system, it also tells you how much energy you are consuming out of it. So it gives you kilowatt hour in, kilowatt hour out. It tells you voltage also, it tells you current also, and it tells you so many things. So you have got a live demonstration of what energy is coming to your system and how much out of that you are using it. There is a watt meter that we normally insert after the panel and before the load, so that we can get a complete specification. For example, I have connected a 100 watt panel. Watt I'm talking, not voltage. 100 watt panel. And I'm running with 20 watt fan, 10 watt bulbs, again 20 watt fan, 10 watt bulbs. With this, I should see that I should not exceed my load beyond 100. Can you imagine? Glowing a 100 watt bulb in an AC and running such 5 to 6 bulbs along with 2 fans with only 100 watt DC. What a drastic change, what a drastic fall, what a drastic saving of energy, you cannot imagine. Similarly, now you can see a 12 volt DC lamp. I have this located in a different place in my department, depending on where the location is possible. But the question is, just a small wattage able to produce large amount of energy. Now this is a AC lamp. AC lamp in what sense? Just to have an experiment purpose, what we have done is, to certain panels we have connected inverter also. For example, you are running a CRO or you are running a generator, signal generator. You don't have any direct accessibility from DC to signal generator. So you need to have an AC for that. So 200 watt panels are contributed to the inverter also. And if you've got an inverter, like any other AC supply, you can run a AC bulb. So I've got a 12 volt AC LED lamp. You can see it's working on inverter. Then one is an important device. As I told you, we require a charge controller between the panel and the battery so that the battery does not get overcharged. Not only that, this charge controller is connected to load also. For example, lot of current is withdrawn by the load and the battery is discharging very fast. Before that battery goes below certain discharge, it has to be disconnected. So this fellow plays a very important role in any solar based system because it saves the battery and load on both the sides. No doubt for saving, we have got fuse that disconnects, AC disconnect, AC connect is a different issue. But at the entrance itself, we got this. And not only that, what important does, if your panel is, for example, 18 volt, normally the voltage written on the panel is more than 12, 18 volt, and you connected a 12 volt battery to it. So if there is sufficient sunlight, then 18 volt will reduce to 12 at the cost of the respective current will increase. And I told you when current is more means you can run more load and our purpose gets solved if I can run more load. A 100 watt panel and a 200 watt panel both will give you 12 volts, but 100 watt when you divide by 12 and 200 watt when divided by 12, current value get doubles. You can run more load from that. So the panel size exactly does not mean more voltage. Panel size exactly means more wattage, and hence the capacity to run more load is more when a panel is big. That's the bigger panel, the more wattage it can have. Voltage remains either 12, it depends, it can be 24, it depends, it can be 48, but normally they are between 12 and 24, and there's not an issue. Two 12 volt panel, if you connect in series, they can give you 24. So it's not very big thing to get a 24 out of that, but then corresponding battery voltage also have to change and everything. That is the role of this MPPT, which is very interesting device. It is called maximum power point tracking, but it's actually a charge controller. Here you can see next is something very interesting. Here you got a bulb which is having a lithium battery inside, exactly like a mobile. And in this case, the interesting thing is you can connect this to exactly as you can connect here. When I'm saying 12 volt AC lamp, this one. But what happens during the whole process, it is glowing because of AC. It is glowing because of AC, and the battery is getting charged because of AC. Exactly like an uninterrupted power supply at home when you got an inverter and all. And then assume AC light is not there. Then this bulb got a switch which you have switched from AC to DC. So the battery which you are charging its ongoing AC mains, that will be used when there is no battery. That means in the houses where there is a normal problem of electricity, till there is electricity, you can work on AC part of it. Once the electricity goes, you can switch over to DC part of it. This bulb is very interesting. I really love this bulb here. And now you can see the next one is your switchboard. Let me tell you, the switchboard of DC loads is not same as that of AC loads. Here I've got a switch exactly like push button switch like, which you can make on and off. And we have got here, if you just see very carefully, we have got these are the switches here, nothing else. This is again display here, which is exactly telling about how much voltage and wattage is coming. It displays everything, temperature, everything. And then here we have got a fuse system. The important part of any electrical network is a fuse system. If anything wrong happens, there is no loss if a fuse goes, but it will save many things. So we cannot avoid using fuse wherever and whenever it is to be. Now this is a 100 watt lamp. This gives you quite a big intensity. One lamp is more than sufficient. That's very interesting, see this fan, which is just working on 20 watt. That is working on 12 volt, 20 watt. So 20 watt if I divide 12, whatever current I get, 1 point something and all, that is sufficient for this to work, and it gives you same comfortability as any AC fans of 60 or 100 watt gives you with a 220 volt AC. Question is, why to go for AC when so many facilities are available with DC? Again, there's a 12 volt DC. There's something very interesting, Light coming from sun is a form of God converting into light, and again illuminating above the God. So somewhere God is responsible for everything. I don't say responsible, God is for everything. Then there is a 100 watt DC LED illumination. This illumination you can see just with 10 watt you can easily illuminate one room. Even if I require 2, it won't be more than 20 watts. That is what you have to understand. Everything is working on DC. So I need not to tell. That is really very interesting. And I can see the specific characteristic of this unit which I'm talking about. This all is running on, for a surprise, only on 200 watts. Except an inverter part which is dedicated to 200 watts. Whatever I've shown you, it is working with just 200 watt panels. Imagine the wattage in which you can just glow 200 watt bulbs in AC. You are able to run so many loads. Our next target is this system we can use as a power supply for the lab and for the lab experiment. So you can imagine at least 10 to 12 power supplies will be replaced by the solar system. And again, you'll be saving a lot of energy. Not only energy, why to buy the power supplies, which is costing at least 4,000 to 5,000 rupees per unit. So that will also save. And then conversion from AC to DC and so on, that all we are out of it. So that's the interesting part. As I mentioned here, whole unit is a standalone. That means neither have an interface nor any interference with the grid and utility. We are not touching the grid part at all. Electricity which I am receiving, I am not interfering, I am not interfacing. It is an independent unit which is running on panels, obviously there are batteries and the load straightway. So either there is a fan, or there is a light, there is a mobile charger, or there is some circuit which is to be run with 12 volt and all. We are able to do with that. No need of any interface with AC. If a surprise, if electricity goes in the college where we have set up this, the only electricity will be available in the Department of Physics, because we already stored a lot of energy in our batteries and all. So we never face darkness. Physics subject anyway does not face any darkness. Let me go ahead. As I mentioned here, the specialty is the short circuit protected, security compliance, smart system, battery protection from overcharging. That is what I told you about the charge controller. Only cost is the installation, and once you install it properly and just clean the panels regularly, the life which is claimed by the panel manufacturers 20 years. I personally feel even if you go for 15 years, you got a lot of electricity free. There is nobody in the electrical department which is going to send a bill for this consumption which I am doing, because I am using totally free solar energy. And as per my calculation, easily we are able to produce 4 to 5 units per day. 4 to 5 units per day means, assume 5 units per day means 150 units in a month. 150 units in a month is more than sufficient for a minimum possible requirement for a house. If you want to go for a enhanced version, for a more loads, you can add and subtract. So it is not costly. It is very economical system. And as I told you, maintenance is to be done periodically with the periodicity of 15 to 30 days. In rainy season, you don't have to clean also. It gets clean of its own. But other seasons being dust and all, it reduces the capacity of the solar panel. I don't say efficiency, because efficiency is a fixed characteristic, but reduce the capacity. So you have to clean it so that the whole intensity falling on it of sunlight should be able to convert into voltage. I hope I'm able to make some sense